Next example. So using all 7 of the following digits, 2, 2, 2, 3, 3, 4, 4, so 1, 2, 3, 4, 5, 6, 7, so using all of them, how many different even numbers can be made that are less than 4 million? So just as a point, if I was going to write things out, so I wrote the numbers backwards, 4, 4, 3, 3, 2, 2, 2. This number is 4,433,222, so that number is more than 4 million. And it has to be less than 4 million. So this number would not do. It has to be even, which means the last number has to end with an even number. Okay, so we're going to have a bunch of different cases here. So how are we going to do this? So the cases are going to be, so in order for it to be less than 4 million, it has to start with a 2 or a 3. So it has to start with a 2 or a 3. I want it to be even, which means it has to end with a 2 or a 4. So what that tells us, so we're going to have our other 5 numbers. We can either start with a 2, end with a 2. Start with a 2, end with a 4. It could start with a 3 and end with a 2. Or it could start with a 3 and end with a 4. Okay, so which numbers are left behind? So if we started with a 2 and ended with a 2, then we have a 2, 3, 3, 4, 4 left. So we have a 2, 3, 3, 4, 4 left. Now how many ways are there arranging that one? Well, that's going to be 5 numbers. So there's 5 factorial ways of doing that. And then there's 2 3s and 2 4s, so divided by 2 factorial, 2 factorial. Okay. That was a little possibly dull. But if we start with a 2 and end it with a 4, then we have 2 2s, 2 3s, and a 4. So there'd be 2 2s left, 2 3s left, and a 4. And that's not very exciting. I'll use a different color just to be clear. That's also going to be 5 factorial over, it's not different enough than the orange. Okay, we'll try a different next one on a different line. A different color on the next line. Start with 3, end with a 2. So it's going to be 2 2 3 4 4. Okay, so if we do that, that's going to be, yet again, 5 factorial over 2 factorial, 2 factorial. So we get the point, right? It's no matter what, it's 5 factorial over 2 factorial, 2 factorial. And so we could probably assume that the last one's the same. Just to be safe, though, let's actually check it. So we use up a 3, we use up a 4. So it's going to be 2 2 2 3 4. 2 2 2 3 4. And when we actually do this one, there's 5 numbers. But there's 3 of one kind. Oh, it's different actually. Patterns are a risky thing. Okay. So what do we get? We figure out that. So 5 factorial divided by 2 factorial, 2 factorial. So that's going to give us, I should probably not use that color. That's going to give us 30, and that's going to give us 30, and that's going to give us 30, and that's going to give us 20. And these are the cases, so we're going to add them up, and we get 30, 30, 30 is 90, plus 20 is 110. So there are 110 numbers that are even and less than 4 million.